Section 4.2, Natural Exponential Functions, Part 3. A 50-gallon barrel is filled completely with pure water. Salt water with a concentration of 0.3 pounds per gallon is then pumped into the barrel, and the resulting mixture overflows at the same rate. The amount of salt in the barrel at time t is given by the following equation, where t is measured in minutes and Q of t is measured in pounds. Okay, so let's look at working with this equation. One thing that we want to look at is that we are dealing with a natural exponential function. We have variable in the exponent, one of the first conditions that we learned, and that our base is a constant. Here we're looking at base E. Base E is approximately 2.718. A special constant like pi is 3.14. E is 2.718. Here's our natural exponential function. Variable t in the exponent. Base, that's a constant. Okay. The amount of salt in the barrel at time t is given by the following. The amount of salt is what Q of t represents, and time is our variable t. Time is measured in minutes. Amount of salt, Q of t, is measured in pounds. When we work with application problems, it's very important to look at identifying your variables and knowing what they represent. When you look at a problem and it asks, say, find this, if you plug in that, knowing what your variables represent makes things a lot easy. How much salt is in the barrel? So that we're looking to find Q. After 5 minutes, we're plugging in a time t. Okay, so let's look at this problem. Q of t is measured in minutes, time. Q of t, amount of salt, measured in pounds. How much salt is in the barrel after 5 minutes? Okay, so let's go ahead and work that out. At 5 minutes, the amount of salt after 5 minutes can be found by taking 15 times 1 minus e to the negative 0.04 times 5. We're just going to go here and replace time by its value. Okay, so let's look at our calculator. Put it over here. Okay, so 15 times 1 minus e raised to the, now your newer model calculators, you don't have to put the parentheses, it'll do it for you. This one's an older model, but all I have available at the moment. We'll plug in our equation, we'll hit enter, and we see a 2.719 solution. Okay, so how much salt is in the barrel after 5 minutes? After 5 minutes, we have approximately 2.719 pounds of salt. Okay, part B. How much salt? Find Q in the barrel after 10 minutes. Okay, so what's going on when t is equal to 10? So we'll plug 10 into our equation. We have 15, 1 minus e to the negative 0.4 times 10. We'll grab our calculator. Remember second and enter. We'll bring up what we typed. You can go back quite a few lines. And what we're going to do is we're going to change that 5 minutes. In part B, we're looking at 10 minutes. Okay, so then we end up with 4.9 0.945 for Q. After 10 minutes, there's about 4.945 pounds of salt. Okay, draw a graph. Use the graph to determine the value that the amount of salt approaches as T becomes large. Is there a level of salt that levels out as T becomes large? 5 minutes, 10 minutes, 50 minutes, 80 minutes, 100 minutes. Is there that value of salt that levels out? Okay, so let's first get our formula put into our Y1. We have 15 times 1 minus e to the negative 0.04 x. Okay, if we go with a zoom standard, a very old calculator, but I don't have a new one on my computer. A zoom standard, remember, is our negative 10 to 10. We see kind of a straight line, maybe not really, because this is starting to sort of taper off. A hint is, okay, so salt that's going to level off as T gets large. Let's go back and revisit our window and see if we can improve on our graph. X is time. Time can't be negative, but I still want to see a little bit of the negative x-axis. We plugged in 5 minutes. We plugged in 10 minutes from parts A and B. Let's go out to 50 minutes and see what happens. Each tick mark is worth 5. Okay, y values. If x is 5, y is almost 3. If x is 10, y is almost 5. So again, we can't have an amount of salt negatives, but we want to see a little bit of that axis. So I'm going to start that at negative 1, and let's leave that at 10 and see what happens. We hit graph. Okay, we kind of start to see that amount of salt kind of leveling off, but we still need to play with our window. Let's go to, say, 100 minutes, and then let's go with, say, 20 for the amount of salt, which was our y-axis. Okay, I'm going to hit trace, and after 49 minutes, we're at about 13 pounds of salt. If we let T get larger and larger and larger, we're at almost 14. I'll let it keep going. 14.3, 14.4. 14.5, 6. Can we guess at where it's starting to level off? What do we think? Let's look back at an equation. Let's look back at our equation. Maybe at 15 it's leveling off. And that's what I'm going to go ahead and guess. Okay, so let me grab the graph. Okay, so we're looking at the x-axis. The x-axis is probably about 0 to 107. So I'm going to go ahead and call this maybe 110. And y is not quite at 15, but if we were to trace more, if we were to look at maybe a scaling, that's leveling off at 15. Draw the graph. The amount of salt approaches 15 pounds.